Question number 53, when you look at your test review, is really kind of an ugly looking problem. And what really makes the problem ugly is that you have fractions within a fraction, which is why it's called a complex fraction. And before I take you to my paper and show you how we work that problem, anytime you see something like this where you have an expression that's a complex fraction, what you want to do is you want to look at all of the denominators in the numerator and all of the denominators in the denominator. In other words, any fraction that's in the top of the problem or any fraction that's in the bottom of the problem, you want to look at their denominators and you want to determine what the LCD is of all of those denominators from both top and bottom, and then what you want to do is multiply through by that LCD, and it in turn will make all the fractions disappear. So let's look at the problem. Alright, so p squared q, pq squared, p squared q, pq squared. This is the original problem. What you will notice in this problem is that the LCD is p to the second q to the second. That will be my LCD. So what I'm actually going to do is I'm going to take that LCD and I'm going to go to the entire numerator and to the entire denominator of this original ugly looking thing, and I'm going to multiply through by the LCD, which is p squared q squared over 1. I'm going to do that to the top, and I'm also going to do it to the bottom. Because remember, nonetheless, this original problem was really just one fraction, one ugly numerator and one ugly denominator. So what I do to the top, I also have to do to the bottom. So follow me through. In the top, we actually have two multiplications to follow through on, and we also have two multiplications to follow through on the bottom. So let's focus on the numerator first. When I take this and I multiply by this, the p squareds cancel, and the q divides into the q squared, leaving me with q times 1, which is q. When I take the LCD and multiply by this time the q squareds cancel, p divides into the p squared, leaving me with p, and p times 1 is p. When I come down to the denominator and I do the same thing, I take this LCD and I multiply by this, the p squareds cancel, q divides into the q squared, leaving me with q. And when I finish, when I take this LCD and I multiply it by this fraction, the q squareds cancel out completely, p goes into p squared, leaving me with a p, and in this case it's minus, because we have a subtraction in the middle. So what we have at this point is q plus p on the top and q minus p on the bottom. Now, what you need to make sure of when you think you are finished with answering a question is if your final answer is in lowest terms. But in this particular problem, of course it is, because q plus p is basically factored as itself times 1. Q minus p is factored as itself times 1, so this turns out to be my final answer. So remember this. Anytime you start off with what is called a complex fraction, any kind of complex fractions this is going to work with. What you're going to do first is you're going to determine the LCD of the entire fraction, meaning you're going to look at all of the denominators anywhere in the problem. Once you determine the LCD, you're going to multiply through by it, multiply through top and bottom. And then the third thing that you're going to do is you're going to make sure that your final answer is in lowest terms. So you're going to try to reduce your final answer by factoring and canceling. And this will work for any complex fraction, this procedure.